Welcome back to Arcade. I am Super Tommy. This is a video series on creating the Pac-Man ghost AIs in Phaser 3. Now, in the last video, we solved the bug at the end. It took maybe 8 minutes longer than we needed. And we implemented Pinky's AI, even though this is Blinky. Pinky's AI, we call it the Intercept Hero AI, which is right here. And then we saw this bug here that the ghost is not wrapping around the screen like Pac-Man does. So first, let's fix this bug, and you'll see we also implement. So this X here is the target that the Intercept Hero AI is using, and this is just to mimic the actual bug in the original Pac-Man in the arcades. You can check out this article, we'll link it in the description to learn why that happens, or this video to get an explanation of why that happens as well. It's got to do with 16-bit integers and storing the vector as both XY components as 8-bit values, or 8-byte values. No, 8-bit values. Okay, we're gonna fix this bug. So here we are. The Ghost AI is not being wrapped. So what we can do, because Phaser comes with a wrap method in the physics manager. No, inside arcade physics. So if we do this dot scene dot physics dot world dot wrap. Let's wrap object, and we're going to wrap this. No, let's give it, there's a padding, let's just say 32. And I think that the bugger here is actually slowing down. Let's just do a refresh. Let's actually close this. Let's see if we can get this AI to wrap. Oh, no. Oh, right. So what we also want to do, okay, it wrapped, but wanted to do none of its logic here if it is outside the bounds of the world. So if scene.physics, the bounds, dot world dot bounds. Let me just think for a second here. Dot bounds. This returns us a rectangle. And then let's see, can we do contains? Okay. So we will only do, so if it is outside the bounds, don't do any of this logic. It's possible that we may have to actually set the physics world bounds before we do this. Let's see. There we go. Okay, so now that works better. So that was the bug. So we used the wrap object built into Phaser 3, and then we check that the ghost is actually within the world bounds before we do any of this direction picking logic. Okay, now we've done Blinky's AI logic, we've done Pinky's AI logic. Now let's do Inky's. So just for things to match, let's actually make this pink. No, new ghost. Let's see. Ghost body, play. Okay, make red, make pink. Make pink. Why is my ghost not changing colors? Ghost, make pink. Set marker. No, ghost make red. All right, there you go. Ghost is now pink. You can also see the circle collider better. Okay. Maybe something slightly odd. Right. It should have gone left. No? Let's think. Well, no, not down actually is closer. No, that's right. Okay. Inky. So let's go to Inky's logic here. Inky's logic. Right. Like it demonstrates here that there are instances when Pinky will actually never hit Pac-Man because due to the set of the board and how the logic works. Okay. Blue Ghost. Inky. So Inky, this one is sort of interesting. Inky is going to be it's going to pick a position 2 tiles in front of Pac-Man, just like Pinky, but then what it's going to do is consider Blinky's position, the red guy, and it's going to project the distance from where Blinky is through the position 2 tiles in front of Pac-Man and end up at right there, let's say. So it's going to, you can also look at it as a taking this vector and then rotating it 180 degrees to get over here. So that's what we're going to do for Inky. So we're going to call this the flank maneuver or the flank AI because it's effectively working with Blinky to flank Pac-Man. So new flank hero AI dot ts. All right, so export default class flank hero AI implements ghost AI, but it's not going to help me out here. Okay, import ghost AI, export, no, only because I haven't finished it here. Ghost AI, ghost AI, okay, implements ghost AI. Oh, yes, that's right, it's not a default export. Okay, let's go here, we need these 3 things. Let's implement that. Return 100, target position. We'll have to calculate this, and direction is going to be, well, we do know, return determine, so we have our determine ghost direction. Determine ghost direction from ghost movement. Determine ghost direction, so we need a target. Okay, constructor, we know we're going to need the ghost, and we know we're going to need the hero, which is Pac-Man, from hero. We're going to need the hero, and we're going to need the board. So phaser dot tilemaps dot dynamic tilemap layer, and okay. So private ghost, ghost, private hero, private board, phaser dot tilemaps dot dynamic tilemap layer. Ghost. Just set this up from the constructor. Okay, and we don't know the target yet. Well, we know it's going to be Pac-Man. So X, Y, this is object destructuring. We went over it in the previous, in parts 2 and 3, I believe. So hero dot body dot position. So it's going to be based on where Pac-Man is, and then two tile spaces in front. So we have, from the hero, we can get the facing vector, and let's just normalize this. So we get a directional vector. And then instead of const, so this is very similar to what we did in the intercept hero AI. We just do it again. So it's going to be x plus the direction times 2 times the tile size, because we only want 2 ahead. And then this is y, y. So the facing vector gives us the direction that Pac-Man is facing as a vector. So if it's facing right, it's going to be x1, y0. It's facing up, it's going to be x0, y minus 1, etc. And once we get that vector, we normalize it to get that. We get the vector, then we multiply it by 2 times the tile size to get the position 2 in front of Pac-Man. Okay, so we get that position. Now we need to know where Blinky is. So this is the one thing where it also needs to know the chasing ghost, we'll call it. And this is an iGhost. And we'll call this a private chasing ghost. Ghost, iGhost. So this particular AI works with the other AI to determine a position. Okay, so now we have the position 2 times in front of Pac-Man. Then we're going to take where Blinky is and then go, I guess there's a math term for this, but we're going to project it through this position, the 2 tiles in front of Pac-Man, all the way to the other side over there. So here's how we're going to do that. So we are going to do, let's say this is partner X. This dot chasing ghost dot physics body dot position dot X. Although I guess I can just do more object destructuring. X, px, y, py. Okay, so we have that. So now we want, call it the dx. This is the delta x of the chasing ghost. Let's think. So in this case, we're going to move that direction. So if we did, so we're going to do x minus px, and then dy, y minus py, py. So this is going to be here, x minus this y minus this y. So we get a vector, dx dy, delta x, delta y. And if then we do x equals to x plus dx, and y equals to y plus dy. So from here, we then add this over, we should get this position, I think. Vector math, I could be wrong. Sometimes I'm confused. Okay, xy. We return that, that's target position, and then const xy, this dot target position, x, y, this ghost, this dot board. Okay, so this is the bulk of the mathematics here. Let's head back to our game and try out this new AI that we just wrote. Let's see, import flank hero AI from game new ghost AI. What did I call it? Flank hero AI. Okay. And then here, so ghost.set AI, new flank hero AI. So we're going to take this ghost, the hero, the chasing ghost. Okay, so here's where we're going to have to make Blinky. New ghost. Just copy this. We're going to move Blinky, so 256 plus 32 is 88. 288. Make red. Let's enable target marker, and this dot add existing on Blinky here. So I'm going to have 2 ghosts in here, and so let's just call this guy Inky. Inky, and Blinky.set AI. We are going to use this chase AI. chase AI, and it's going to take Blinky. And then this, that's the chasing ghost, is Blinky. And then the stop word layer, that's the AI. Just move this out of the way. And we're going to add existing Inky. And Inky is not pink, Inky is blue, or I called it teal. Okay, let's see. There they are. So there's one X that is on top of Pac-Man, and one X that's, let's see, is that right? That's just, so 2 in front of Pac-Man is here, so that X is correct. So we're just projecting it from where Blinky is, right? Let's just go somewhere else and test. So 2 in front of Pac-Man is right here. And so we're doing, wherever Blinky is, it should basically be the inverse of where Blinky is, or I don't know how to describe it, but away from Blinky, from the distance he is from Pac-Man, 2 pixels up. So there we go, that actually looks correct. These X's are not in the exact right order placed, it seems like. Although, I know why. I just need to offset it by 16. Let me just fix that, so that it looks easier to reason about here. Let's see, my x plus 16, looks like it's y minus 16. So 2 in front of Pac-Man and then projected through that point based on the distance. Yeah, that looks right. So let's now color these X's so that we can actually get a better feel for this. So ghost. When we set the tint, what we can do is we have this text marker dot set color. And of course, color takes a string. So it wants this. There's probably an easier way to convert this, but it's also plenty easy to just do this as a hex and string instead of hex as number. And I guess I maybe could 2-string it. That actually may work. But let's just quickly set these. Okay. So now we should see these markers. Okay, there's the red one on Pac-Man. Then there's the teal one. So that looks good. And so that's Inky flanking Pac-Man using Blinky as help. All right, so that was Inky's AI. We have one more AI to go, and that is Clyde's AI. And given Clyde's a different name than everyone else, a different type of name, Clyde's AI is going to be a composite or a composition of Scatter AI and the Chase AI. So come back for the next video. We're going to go over Clyde's AI.